Topic 2-1, Part 1, Solving Two-Step Equations. Let's take down the definition of an equation. If you need to pause the video, do so. An equation is a mathematical sentence that includes an equal sign to compare two expressions. Looking at this first example, example 1 is an equation. It has an equal sign, terms on the left and terms on the right. Let's solve this equation. To solve an equation, we want to solve for x. To solve for x means to get x on one side by itself. When I look at this equation, I have the term positive 3x. 3 is a constant. 3 is being added to 3x. To undo addition, we must subtract 3. What you do into one side of the equation, you must do into the other side of the equation. So what I must do first is subtract 3 from both sides of your equation. Your equal sign is your wall. You see that I've subtracted 3 from the left side and 3 from the right side. When I subtract 3, the 3's cancel on the left side, leaving 3x is equal to 7 minus 3 gives you 4. Continue solving this equation. 3 is being multiplied times x. To undo the multiplication, we must divide both sides by 3. 3 divided by 3 becomes 1. X equals to 4/3. I am finished with my equation because I have x on one side by itself with a positive 1 in front of x equal to a number. So my answer is 4/3. You can check every equation that you solve. To check, you will take the original problem, 3 plus 3x equals to 7, and you will substitute in your answer 4/3 in for x. So I'll have 3 plus 3 times 4/3. Does that equal to 7? What we want to do is see if the left side of the equation equals the right side of the equation. I have 3 plus, we need to multiply 3 times 4/3. Think of 3 being over 1. If you multiply straight across, you get 3 times 4 gives you 12. 1 times 3 gives you 3. Does that equal to 7? Reducing my fraction, 12 divided by 3 gives you 4. Does that equal to 7? And last, 3 plus 4 gives you 7 on the left side and 7 on the right side. So this is how we check our answer. So if you get the left side equal to the right side, then you know your answer of 4/3 is correct. This is solving an equation. Your goal is to get the x on one side by itself with a positive 1 in front of x. Let's look at another example. Example number 2. Example number 2. This is an equation, has an equal sign, terms on the left, terms on the right. Let's solve this equation. The only variable I have is x. X is being divided by 2. Plus 5 equals to negative 10. I need to isolate my variable term. My variable term is being added by 5. The opposite operation of adding 5 is subtract 5. So the first thing we would do, or the first step we would take, was subtract 5 from both sides. Remember, your equal sign is your wall. What you do unto one side of the equation, you must do unto the other. The 5's cancel, leaving x divided by 2 equals 2. Negative 10 minus 5 is negative 15. X is being divided by 2. We need to undo the division. The opposite operation of division is multiplication. So we need to multiply both sides by 2. Multiply both sides by 2. 2 is over 1. When you are multiplying fractions, you can either multiply straight across or you can cross reduce. The 2's will cross reduce or cross divide. The 2's cancel out because 2 divides into 2, 1. 2 divides into 2, 1. Leaving 1 times x over 1 times 1 would just be x is equal to negative 15 times 2 gives you negative 30. I'm going to circle my answer for example number 2. Let's check our answer. To check, take the original problem and substitute your answer in for x. And we're going to see if the left side equals the right side. So I'm going to substitute in negative 30 in for x. Negative 30 divided by 2 plus 5, does that equal to negative 10? That's our question. Dividing negative 30 divided by 2 gives you negative 15 plus 5 equals to negative 10. Continue solving on the left side. We're adding negative 15 plus 5. Recall your rules. If you are adding with unlike signs, subtract and take the sign of the larger. So 15 minus 5 would give me 10. Sign of the larger, 15's larger, therefore I have negative 10. Negative 10 equals to negative 10. So yes, my answer is correct. Therefore, my answer for example number 2 is negative 30. Next, let's look at example number 3. Example number 3. With this problem, I see that I have a decimal in this problem. I could work this problem by keeping the decimal, but there's an example in your homework that shows you to eliminate the decimals by multiplying each term through by 10 so that you can eliminate this decimal. So what you can do is multiply each term through by 10. If you multiply each term through by 10, you can eliminate the decimal. If you notice, this number has one decimal place. By multiplying a number by 10, it moves the decimal one place to the right. So if you have 10.7 times 10, you actually just get 107. It moves the decimal to the right 1. Equals to 10 times x gives you 10x. Minus 10 times 43 would be 430. Now that is one way to work this problem to eliminate the decimal. When you see that you only have one decimal place, you can multiply it by 10. If you have 2 decimal places, you would multiply it by 100. So now let's solve for the variable. 10x is being subtracted by 430. The opposite operation of subtraction is addition. So let's add 430 to both sides. I end up with 537 equals to 10x. These cancel. Next, divide both sides by 10. Divide both sides by 10. If you divide both sides by 10, x is equal to 537 divided by 10 gives you 53.7. 53.7. Now you can divide that by hand if you want to. 10 divides into 537. 10 divides into 53 5 times. 5 times 10 would give you 50. When you subtract, you get 3, bringing down your 7. 10 divides into 37 3 times. 3 times 10 gives you 30. Subtract, you get 7. To continue dividing, you'd add a decimal and a 0. So bring down your 0. Also bring your decimal up. When you add a decimal and add your 0, you need to bring your decimal up. Now, 10 divides into 70 7 times. That's how you would divide by hand. So that is the answer to this example number 3. Now, I'm also going to work this example, same example, but I'm going to work it by keeping the decimal. We can work this problem by keeping the decimal. To solve this problem, we want to get x on one side by itself, so let's add 43 to both sides. Now remember, 43 has a decimal. It's behind the 3. Remember, when you're adding decimals, you line up the decimals. So the 43's cancel on the left side. I have 10.7 plus 43.0. Notice my decimals are lined up. So I have 7. 0 plus 3 is 3. Bring down your decimal. And 1 plus 4 gives you 5. Equals to x. You see that's the same answer that I got earlier when I eliminated the decimal by multiplying each term through by 10.